Hi everyone, and welcome to the 19th webinar in AWC3's webinar series about watercourse crossings. My name is Daniel Monaco and I'll be acting as your host for today's webinar. Before getting into it, I just wanted to give a brief introduction to AWC3 in case this is the first webinar in the series that you're attending. So AWC3 is the Alberta Watercourse Crossing Collaborative, and it's a not-for-profit organization whose primary objective is to facilitate information transfer around the issue of watercourse crossings in Alberta and their impact on native fish species. So that's what this webinar series is all about, sharing information from subject matter experts and trying to get that information out to as many people as possible. Since we have received some questions about this, I wanted to let everyone know that this webinar can be used for continuing competency credits with professional associations. So it counts as half an hour of credits and has been approved by most major professional associations. So if that is something you're hoping to take advantage of, please keep all of your receipts in your registration confirmation email. And if you have any questions about this, you can email us at info@awccc.ca. So today's webinar is about watercourse crossing data management and restoration plan development and submission. And I will actually be your presenter for today. So to give a bit of background on me, my educational background is in biology with a Bachelor of Science from McGill University. And I also have a diploma in biological science technology from NATE. So I've been working with Woodlands for over 3 years, starting out as an ecology field technician, performing watercourse crossing inspections, and now overseeing watercourse crossing projects. So my experience around watercourse crossings with Woodlands has been extensive, and I have had a chance to see the program at all levels, giving me some good insight on how things work. Part of this is the data management and quality control process, helping to design and maintain large watercourse crossing data sets, helping to design mobile data collection applications, and using my knowledge to assist with the completion of restoration plans. So that's what today's webinar is going to be about. So before moving on to the presentation, if anyone has questions throughout the presentations, please feel free to submit those through the GoToWebinar program. I'll be compiling those questions at the end and going through them and answering them to the best of my ability. I'll also have 2 panelists to help answer questions. So Bruce Nielsen, who is the General Manager of Woodlands North, as well as Javed Iqbal, who manages a lot of the data on the back end side of things. He works with Alberta Agriculture and Forestry. So I would also like to ask that any questions that are being asked do pertain directly to the topic of the presentation so that all of our presenters and panelists can answer those to the best of their ability. So let's jump into this. So yeah, like I said earlier, the presentation is on watercourse crossing data management and restoration plan development and submission. So that's me. I'm your presenter today. I've already introduced myself, so I won't go into that again, but my email address is here. So if you have any questions, feel free to email me. Yeah. So to start things off, just give a bit of a background on what the issue is and what we're talking about here. Excuse me. So if you have attended some of the other webinars in this series, you should have an idea of the magnitude of the problem of watercourse crossings in Alberta. With the amount of roads built throughout the province, we have estimated that there are approximately 152,000 watercourse crossings throughout the province. With the sheer number of legacy or historical crossings that exist, the time and resources needed to address this problem in its entirety make it impossible for every single crossing on the landscape to be addressed and fixed. And new ones are being introduced every day and being installed incorrectly still. So this is an ongoing problem that we're all trying to work towards addressing. As a way to begin addressing this, the government of Alberta, specifically AEP, began the Watercourse Crossing Management Initiative, which involves various measures. Under the new Alberta Watercourse Crossing Initiative, one of these measures is the Roadway Watercourse Crossing Management Directive. There it is. This directive states that road owners in Alberta must be aware of the state of all the watercourse crossings that exist on their roads, spatially report this information to the regulator, and plan to restore those crossings that are found to be non-compliant with the GOA inspection protocols. If this is done, there's an agreement between regulators and road owners that self-reporting of non-compliant crossings and showing a plan to address those crossings will prevent those road owners from receiving orders to remedy specific crossings that are inspected. So participating in this type of work requires collecting extensive information on hundreds or thousands of crossings. So managing all that information can be a challenge. So that's the topic of today's webinar. I'll be giving an overview of collecting and maintaining a data set, some of the challenges to managing a large watercourse crossing data set. I'll outline some strategies to go about that, and finally how to turn that information into a restoration plan that satisfies the requirement of the GOA and will allow tenure owners to plan resources accordingly. So in the end, the message that I want everyone to take out of this is the importance of collecting and maintaining high quality data and why you should value this information and use it to your advantage. It allows you to control your own resources so you can manage what you know and what you can measure. You can allocate time, finances, and materials in a way that produces the most efficiencies for your organization. And you can avoid getting orders from AER or AEP to fix specific crossings so that you can decide which makes the most sense for your organization and which will have the biggest impact ecologically for the effort and resources you put into it. So here's a bit of an outline of how we'll go through things. I've already mentioned this, but we'll talk about data management, go through some of that, and then restoration planning afterwards. Okay, so we'll talk about some of the challenges to data management first. So an important consideration for managing data is the source of that information. So data for watercourse crossing comes from inspections performed by qualified inspectors. This involves traveling along resource roads, sometimes to remote sites, looking for crossings and performing inspections that can take anywhere from 10 to 30 minutes. Like any data collection, this information needs to be recorded, stored, transmitted back to a central location, and compiled to be used later. The data collected rely on the expertise of the person performing the inspection and the reliability and consistency of the medium through which the data is recorded. So it's important to consider in advance all of the issues that may arise during this process and plan ahead to minimize the risk of collecting bad data. At the end of the day, having high quality data is important because the conclusions you can draw from that data are only as good as that data. So one of these challenges is inefficient data collection. So as I said, it can be very time consuming. So the process involves traveling out in the field to collect data. It can be time consuming and laborious, and especially when considering access limitations on remote resource roads. So to note here, the safety of the surveyor is always the most important part of any field trip. So cutting corners to make this process more efficient is not really a possibility when you're considering keeping it as safe as possible. So this means that you don't want to waste any time when you're actually out in the field. So planning ahead will allow field inspectors to make the most of their time in the field. So it's a terrible feeling to realize once you've arrived in the field that you don't have all of the equipment that you need to perform your inspections, or to realize once you've arrived back in the office that you need to make a second trip to the field because you forgot something or your data set is incomplete. When you have to travel upwards of an hour to collect a single data point, that cuts into a project's productivity and quickly degrades your budget. Another issue is inconsistent data. So data can often be inconsistent when you have multiple people out collecting that information. So this is especially difficult when data is coming from people in different organizations with different backgrounds and experience, and who may have different perspectives on these watercourses that they're inspecting. Inconsistent data makes it impossible to draw meaningful conclusions when looking at developing a restoration plan later on. So as an example of this, I've seen firsthand, I've seen firsthand that even though all inspectors were properly trained, given reference material and provided with a standardized way of collecting data, and feedback was even given to those inspectors, we had information submitted to our SCARY database, which is Woodlands' own proprietary program for data collection and management. So I saw that the data coming in did not line up with the rest of our inspection information. So looking at measurements like culvert diameter, the numbers just didn't make sense. So my best guess is that the inspector was taking measurements in inches rather than in millimeters, which completely skews the results that you draw from this information. And basically it means that any information collected by that person is no longer usable. So that's a waste of time, it's a waste of resources. It's just not a most useful way of collecting your data. So there's also certain situations in the field that may be ambiguous and therefore the call may be made by the inspector may be different from person to person. So I've seen this happen with things like stream classification, where a stream shows characteristics between two classes, and whether or not that stream is fluvial, which is a sign of whether or not the stream is fish habitat in the foothills region, those calls can sometimes be subjective. So there are guidelines, but streams don't always follow those guidelines. So then you rely on the better judgment of the inspector in the field. So trying to address those issues up front are really important. And the only way to get around that really is to, like I said, train the person up front, and then also review the information on the back end so that you can add other information to it. So let's say when you're talking about stream classification, for example, you might want to look at that creek through aerial imagery from a desktop, and then you can see, does the creek look the same size as it does at the crossing, and does it look like what the inspector saw at the crossing? You can see if that stream is connected to a larger water system. That would then also indicate the stream class. So high quality data is important for restoration planning to ensure that resources are properly allocated on a landscape level. So for example, a road owner wouldn't want to spend $50,000 to replace a culvert on an ephemeral stream that wouldn't support fish of any kind. So in the end, you're putting money towards something and you're not actually getting those restoration outcomes of improving fish habitat that the whole program is intended to have. So rather, a better use of those resources is to restore a crossing on a small permanent stream so that trout species can reach spawning habitat upstream of that crossing. So in this picture here on the right-hand side, this is just an example of incomplete data that we receive sometimes. You can see this whole top part of the form was not filled out. This was page 5 of a 5-page data sheet set, and those sheets got separated, and then this data becomes completely unusable, and we have to go back into the field to collect it again. So those are the types of things we want to avoid. Another issue is data storage and transfer. So storing data is something that needs to be closely managed and watched. So when collecting data, there are various ways to do this and to store that information, but there are usually still some risks for some of that data to be lost. So with paper data sheets, for example, pages may get lost, may get torn out, they might get wet, the information might not be legible. You also rely on the inspector's handwriting, which is always a bit of an unknown when you're going out there. So try to manage that to the best of your ability. And then inspections, sorry, lost my place here. There are alternatives to paper sheets, and these are things like doing data collection digitally through a tablet, which is what we do as a company, and what the government of Alberta has released a new app to help with data collection. So that's another great option, but it isn't without its downsides itself. So technology can be unreliable, batteries do die, apps crash, things like that. So nothing that you can do is always going to be 100% reliable. So whatever your choice for data collection, it's important that the method for collecting data is as reliable and consistent as possible. So that's a nice part of having a digital way to collect that data. That's always going to be a little more consistent because the apps can have built-in ways of checking your data as it's entered, and it'll validate that information while the inspector is still out in the field. So if something was entered incorrectly by accident, the inspector is still on site and can collect that information again. So an important point to make here is you always should have backup methods in case something goes wrong. So if you're using forms, make sure you have backup forms. Make sure you have extra pens and pencils. If you're using a tablet, make sure you are carrying charging cords with you and maybe a charging pack or something like that, so that you can there are other options that you can use if the tablet were to die. And then back up the data at any chance that you get. So you can build administrative controls into an inspector's daily routine to avoid losing information should something happen at a later time. So for example, with paper forms, you can take photos of those, or you can scan them at the end of the day, or set times throughout the day. And you can send electronic copies of the data to a centralized location or store it on some sort of secure cloud storage where it can be retrieved later. So that's some of the issues. Here are some of the solutions and the considerations for those things. So there are many steps that need to be taken to make sure that the information is collected efficiently, and that's ultimately going to be useful in planning out restoration efforts. As an organization, be it a service provider, road owner, etc., there are lots of items that need to be considered in order to keep your data organized and of high quality. So some of these steps have been taken already by the GOA, but I believe that's important for any organization to manage those things internally as well. So like I mentioned earlier, the GOA has developed an app that people can use for data collection. There's an inspection form to kind of standardize the process. These things are great as measures taken by a body that oversees this whole program, but it's important to also manage those things on an individual level. So let's go through some of these items that I'm talking about here. So planning is very important. So this is something that you should be doing before going out into the field to collect the data in the first place. You should be reviewing roads spatially beforehand. So for watercourse crossing data collection, you want to know or have an idea of where those crossings may be. So you should review creeks and watersheds beforehand to prioritize certain areas. And you can predict where those crossings will be. Excuse me. You want to predict where those crossings will be to provide inspectors with as much information as possible before going into the field. So this will also help plan logistics, and you can set up a targeted inventory where you'll know how much time needs to be spent in each area, and that'll help plan things out, like I said, logistically. It allows you to target the most important areas or crossings so that you can be sure that the data collected is fully capturing the whole picture and representing the state of the crossings on the landscape. So once you know where you're going, make sure that your inspectors are properly trained. So extensive training for inspectors is recommended. You want to ensure that all inspectors have, at the very minimum, the base knowledge necessary to complete an inspection. You want to make sure they're doing that in an informed way. So this reduces the amount of subjective calls that need to be made in the field. And you can even have sessions like we do every year where we have the representatives from AP and AER and other service providers, and even from industry. We didn't have one this year, unfortunately, because of the COVID situation, but we do one of these every year. We get everyone together and we go out to creeks and everyone performs these inspections, and then we discuss what everyone has found. And that helps us to calibrate everyone's eyes and everyone's judgment when they're out in the field, so that standardized across the board between different service providers and between anybody who might be looking at a creek, we're all looking at the creek in the same way. You also want to perform quality control on their fieldwork, but that'll come at a next slide, I think, or maybe one more. So you want to standardize the data collection as much as possible as well. So you want to provide inspectors with tools to collect data in a standard way. So training is part of this whole standardization process. But you also want to do this through providing maybe a mobile application, providing inspection forms with standard fields that need to be filled out in specific ways. In that way, everybody's collecting the data in the same units. They're all making the same calls. You're providing them with maybe reference material so that they can look back if they're not sure about a situation they're looking at. Just basically provide them with all of the tools that they need. So examples of this would be to develop or acquire a mobile application so that data can be collected digitally in a format that can easily be reviewed, using data sheets like the GOA's roadway watercourse crossing inspection form to collect information in a standardized format. This is a great tool, but your organization may want to collect more information to better serve your own needs. So mobile apps can ensure consistency and completeness and eliminate double or triple handling data. So that's an important point as well, is every time data changes hands, so every time it's passed off from one person to another, and every time it's looked at and recorded or manipulated in some way, there's always risk that the data will get altered or somehow lost. So if we can reduce the amount of times that happens by making the whole process digital and automated, the data is better off for it. Quality control is also a huge part of this. This is, in my opinion, one of the most important parts. So there are two ways to do quality control. So you can do office review or you can do field audits. So a desktop review of the data, it can be very time consuming, but it's extremely important. So reviewing that data can ensure that the training that you're giving to your inspectors is effective, and make sure that the calls that they're making are consistent across the board, that everybody is looking at these things in the same way. And then that allows you to give feedback to them later on, so that you can make adjustments in the way that people are doing things, or if maybe the procedures that you've put in place for inspections are maybe not as efficient or effective as you thought they would be, you can make those adjustments as you go if you're performing these quality control measures. So a desktop review involves reviewing data collected at the desktop to ensure that data fields agree with one another, and that your data is complete and consistent across the board. For this, you can look for things like extreme values. So, a stream width that you're expecting to be 60 centimeters, but is actually 600. That's quite a big difference, and you can usually tell that from photos or other characteristics that were measured at the crossing. So you want to make sure that everything is complete and it makes sense. And you can also review additional information. Like I said earlier, trying to look at aerial imagery to decide on a stream class. That's something that you can do from a desktop level. The other side of this quality control is field audits. So you can send out someone who is maybe more experienced, a senior inspector, and they can double check some of the inspections that were done in the field previously. This provides just a way of double checking that the calls being made in the field are the same from one person to another, and that every inspector is really understanding what is going on and how to do it. And then this is another piece that is again, very important. It's kind of closing the circle. So making sure that once you've done that quality control, that if you're noticing common errors, if you're noticing problematic patterns, that those are being addressed, that information needs to be communicated back to the inspectors so that they can make those adjustments. Yeah. So just some examples of programs that I know about personally. I know that there are some other ones that exist, but I'm just going to talk about these as examples. So the first one is SCARY. So it's the Stream Crossing and Aquatic Resource Inventory. So as an employee of Woodlands North, this is the one that I'm the most familiar with because this is the one that we have produced internally. This is by no means the only or even the best way of doing it. I mean, my opinion is biased, but I think it works really well. But there are other service providers that have their own systems that work just as well. So I don't want to, yeah. So Woodlands developed this system so that we can use it for our energy and forestry clients to perform inspections, organize and store data securely, and make that information available to our clients. So it consists of a mobile application, an online dashboard, and a training manual. So the mobile application has some built-in quality control measures from the beginning. So if you record a value that is outside of a range that would be expected to be normal, for lack of a better word, it'll flag that as a problematic value, and you'll have to verify that in the field before going back to the office. If there's any information that's missing, we collect photos as part of our inspections, and that's built into the app as well. So if you don't have a complete photo set, that type of thing will get flagged, and you'll have to go take those photos again. Another really important part of this is the spatial aspect. So when you're in the field collecting data on a paper form, you can write down the coordinates, but that's something you don't need to do when you have a device that has a GPS system built into it. The coordinates will be automatically recorded from your device's internal GPS system. So that's a huge advantage of having this in this way. So all that information is collected on the mobile app. It's transmitted directly from the app to a secure online database. And then that information can be accessed through an online dashboard, which we make available to our clients. And then road owners can go into this dashboard, which is kind of hard to see, but you can kind of get an idea on that. The photo on the right-hand side, that laptop, it's a mapping tool. So you can see from a spatial perspective where your crossings lie, which ones are higher risk to fish, that kind of thing. You can visualize that all right from the dashboard. And then the last component is this training manual. So we've standardized our process. We've built this training manual to coincide with the mobile application so that everybody has all of the knowledge that they need to perform an inspection, and that information can be referred back to later. So I think it's a great system that works really well. If you're managing large data sets, something like this is always a good idea. It really keeps everything in one place. It keeps it organized, and it's much easier to keep track of, especially when you have people out collecting information every single day. You need to be able to track that and have it stored securely, so that this program allows us to do that. Another example of a program is ABWCI, so the Alberta Watercourse Crossing Inventory is the name of the app. So the government of Alberta has just recently developed a similar mobile application for facilitating data collection and transfer. So it's called ABWCI, as I said before. It's similar to SCARY in the way it works. So it consists of a mobile application and an online dashboard, but this one belongs to the government. So it's available publicly so that anyone can download it. So anyone who wants to perform an inspection can download the app, but the form and the detail that you enter into the app will depend on your credentials. So if you are just someone who is interested in watercourse crossings when you download the app, it'll be quite a limited form, but you'll still be able to go out, collect information, and transfer that back to the GOA's database. If you have more experience, you have affiliations with an organization that is qualified or deemed qualified by the GOA to perform these inspections, you can contact them and have your account upgraded so that you have access to the full form. So this is a great way to collect information. The format of that data will be standardized to the GOA's inspection form, and that information will get transferred to them directly in their preferred format. So this really takes a lot of the work off of the inspector and the organization doing the inspections, and just gets the information right to the GOA from the beginning. So it's a pretty effective way of doing this. Like I said, it is publicly available, and I have some links here to where to download the app. So it's available on Android and iOS. You can just search ABWCI and it should show up. If not, I have some links here. So if that's something that you're interested and you're not able to find it, you have my email address, so just email me and I'll forward you these links. So that's it for the data management side of things. We'll go into restoration planning. So I'm a little behind in my time, but that's okay. We'll move into the restoration planning part of the presentation. So the final step of the inventory and data management is to bring that information into a spatial restoration plan for submission to the GOA. So while the GOA requires spatial data sets and a list of sites to be restored, this process cannot be effectively maximized without looking at the bigger picture of the crossings on the landscape and in relation to one another. So to give an example of that, I guess I'll go through first, what are the main benefits of having a restoration plan? I'll give, and then I'll go through how to put that together and submit it to the government. So to really communicate the benefits of having this plan, I'm going to present a case study, which is the Beaver Creek watershed, which is a Huck 10 watershed within the Berland River Huck 8 watershed. So like I said before, the important thing here, the key is to look at the bigger picture and make decisions on the landscape. So rather than looking at individual crossings, we're looking at how those crossings relate to each other, and then putting that information into a plan to have a real impact on fish species. So as I mentioned earlier, knowing what your roadway watercourse crossings look like on the landscape helps you to make informed decisions that prioritize the restoration works to be done and gives you better control over the fate of your crossings and ultimately for your company. So getting into this case study now. So this is the Beaver Creek watershed. So when you start your planning, you're looking at a number of crossings over a large area. So this area, as an example, has 25 crossings in it. So it's normal to look at these crossings in terms of the roadways and connected infrastructure for your operations, but you may have to step back and look at it ecologically from the perspective of connectivity of the watercourses. So this watershed is a real-world working example of a highly fragmented watershed where multiple barriers have rendered much of the viable habitat unusable. So as in all areas like this, there are often multiple companies within one industry or maybe multiple industries and stakeholders working adjacent to one another. So while each of these individual entities will manage their watercourse crossings independently, as they should from a business perspective, someone such as the GOA should be looking at all of these areas in a comprehensive manner from a creek's perspective. So just to have an idea of what you're looking at, this area has lots of crossings in it. So each green dot that you see here is a crossing. So the yellow dot on the top right-hand corner of the watershed is where the entire watershed connects to the Berland River. So any fish that is in the Berland River, so there are lots of trout species that would access this watershed for spawning habitat, they're not able to access this area without going through that initial point, that is that yellow crossing. So if we want to make that area available, we want to try to address as many of these crossings as possible. So each one of them is acting as its own barrier to fish passage. So behind every barrier is a sub-watershed, and without connectivity to the stream reaches below, that habitat above the barrier is isolated, unusable, and not able to contribute to specific life stages such as spawning or rearing of new generations. The sub-watersheds will vary in size and also in ecological value depending on the amount and the quality of the habitat. So the more valuable habitat is often that which is connected to form contiguous stream reaches, and generally speaking, the lower down in the watershed, the more valuable that habitat is. So sub-watersheds here in this example can vary in size from less than 1 square kilometer to upwards of 240 square kilometers. So you can see how those being different sizes and different amounts of habitat, they would have different value. So, and I guess one other thing to mention here is certain sub-watersheds will build off of each other. So one watershed might flow into another, or it might be part of another bigger sub-watershed. So even though you're addressing a crossing and opening up habitat, if you have another crossing upstream that is also acting as a barrier, that's something else that needs to be addressed to open up as much habitat as possible. So moving on with this example, if operators are to repair individual roadways and crossings based on their operational needs or in isolation of other watercourse work going on around them, they will most likely not consider connectivity of many watercourses or connecting longer reaches of one watercourse. So in this example, there are 5 crossings being addressed, and there's no connectivity of habitat or sub-watersheds to one another. So nor is there connectivity to the larger Woodlands River below. So this is a real scenario where direction to fix individual pieces of the road or crossings are given based on a road network maintenance schedule, but no consideration is given to watercourse network running beneath the roads. So you can see here these larger points that are at the base of these yellow sub-watersheds are the ones that in these situations are being addressed. So if you're just looking at the crossing, you might think, okay, well, it's opening up all of this habitat above the crossing, which is a great way to look at it, but you're ignoring the fact that there is still a crossing downstream that is preventing fish from even reaching this sub-watershed to begin with. So if you were to address just these 5, any fish that is in the Woodlands River would not be able to reach any one of these. And then this is an example, this is showing what this example could be. So by looking at all of the crossings from a watercourse and or sub-watershed perspective, fixing 5 different high-risk crossings will connect half of this previously fragmented watershed with the downstream Woodlands River. So as a note here, there could have been hundreds of operational variations of repaired roads and restored watercourse crossings in this Beaver Creek sub-watershed alone. And this particular outcome is the ideal scenario with only 5 fixes being completed. So with the varying degrees of value of each of these watersheds, you can see how of the 25 crossings, you're only addressing 5, but you're making half of this habitat, you're connecting half of this habitat again and making that available to fish. So that's why it's important to take the time to inventory and understand the scope of the problem you're trying to fix. And it's not easy to assemble all the information, but that's needed to achieve an ecological, the best ecological outcome. So to do this, you'll have to pull together, well, to build a restoration plan in general, you'll have to pull in lots of pieces of information, and that'll include operational road and budget data from your operations. You'll need road and crossing data from other road owners and operations, ecological stream reach data, and understand species distribution. But you have to keep thinking of scale. So while one road and one creek restoration is okay, it may be totally ineffective if it's done independent of its surroundings. So what about watersheds and what about subwatersheds or larger watersheds, excuse me? This is where proper data management is vital to the success. So now this information has been applied over a much larger area. So Beaver Creek is a Huck 10 watershed. So it's a landscape scale of 1 to 500,000. And then the Berland River is a Huck 8 watershed. So it's a 1 in 250,000, or a regional scale. So that's a much larger area. I think there's some animations here, yeah. So looking at just Beaver Creek, which is the part that's highlighted in red in that watershed, you can see how that relates to the larger, Berland River watershed. The Berland has 8 Huck 8 units, or 8 Huck 10 units, sorry, and is over 316,000 hectares in size. So the Beaver watershed is 12,400 hectares in size. The inventory of the Berland took 1 year and has 1,124 fluvial crossing points. So that's a lot of crossings that could potentially be barriers to fish passage on this landscape. And then this yields a regional scale restoration data set that covers across industries, companies, and all stakeholders. So the data set that was collected in the Berland was done for every road, every crossing. It even took into account smaller trails and things like that. So this really takes into account every single possible crossing that there could be, any possible structure or linear feature that could act as a barrier to fish passage. So that shows why this is important. And now we'll go into how to build a restoration plan. So what information is required to go into a restoration plan to be able to make an informed decision? So the required information, I won't go into too much detail about this, but so the AEP has released an inspection protocol to follow in the roadway watercourse crossing inspection manual, which follows their field inspection form. So because this has been, the inspection process has been covered, excuse me, by Jordan Hayes in the previous webinar. I'm not going to go into detail about this, but the information in the form is all the information that is collected through the ABWCI mobile application. So that's something that Jordan did speak about in her webinar. But that is kind of the base data that needs to go into building a restoration plan. So this will allow you to determine the degree to which a crossing is posing a risk to fish passage, along with other risk factors such as erosion and sedimentation. The form will collect all the information that is necessary to determine whether or not the crossing in question is compliant with GOA standards. Oops, sorry. What is missing from this form is additional information that allows you to assign an ecological value to the crossing and therefore prioritize it against other crossings in a watershed. So for this, you can either collect more information at the time of inspection. So that's something that we do with the Scary app. We use the GOA form as a base, and then we build off of it. And I know other service providers have done the same thing. Or you can use geospatial data to assign value later on from a desktop point of view. So for example, one of the major metrics used is the length of upstream habitat that's made available when a problem crossing is removed as a barrier to fish passage. So this provides an easy way to measure one crossing's value over another. It can be done easily by just looking at where the crossings lie, where the roads fall, and where the streams are. So this is the form, the GOA's inspection form. And then finally, submitting to the government of Alberta. So when information has been collected and restoration has been fully planned, data and plan summaries need to be transmitted back to the regulator. So information should follow the format provided by AEP. So that's the format of the inspection form. And restoration plan summaries should follow the form that you see here on the right-hand side of your page. So this form is still a draft, so the format still needs to be finalized. But I've provided a link here, which again you can contact me if you want this link. But this is a link to an information package that was put out by AER in June of last year. So it contains information about the latest draft of the directive, as well as some details about reporting requirements. So much of the content in the package is still in draft form. So keep that in mind, that it's already been released for a year. So some of this has already changed. But it still is good for giving you an idea of what information AER is looking to receive from a restoration plan. Yeah, so if you're participating in the Government of Alberta's Watercourse Crossing Initiative, the requirement under the directive is to report on non-compliant crossings, as well as submit these summary reports. So the inspection data only needs to be submitted for non-compliant crossings. So you'll actually submit the information, the data that was collected at the crossing. So that's when that ABWCI app is very useful, because that information is already stored in one place. It can easily be transmitted in the proper format by just hitting a button. So it's very simple. You don't have to go through a bunch of formatting and then transmitting data in a way that you feel secure with. It's all done automatically. But one of the downsides is that information just goes right to the GOA, and then you don't have access to it anymore, at least not right away without requesting access. So these restoration plan summary forms should be done on a Huckgate watershed basis, and a form should be submitted for each Huckgate that you own roads in. And a summary, the information contained in the form is limited, since the specifics of the individual crossings is contained in the inspection data that you are also required to submit as part of this program. And I've already mentioned that it is still in draft form, so note that it could change still. So in conclusion, this is just an overview of the points that I've already gone over. So again, the take-home message here is just how important it is to collect and maintain high-quality data so that you can make all of these decisions in an informed way. So they're not easy decisions to make. There's a lot of considerations that play into crossing restoration planning. So you want to make sure that the information that you have coming into these decisions is as complete and informative as possible. Yeah, so thank you for listening to me. That went on a little longer than expected, so I apologize for that. So let's go into the Q&A portion right away. We only have about 12 minutes, and again, sorry that this took so long. I do say at the end of every one of these webinars that if you have questions, please submit them, even if we're not able to get to them in this time. A transcript of the Q&A portion will be distributed eventually, and all of these questions will be answered in that form. So let's just jump right into it. So the first question here is, if staff use SCARY and submit their inspection, does it become data that can be used by Woodlands? So the answer is, if you use the SCARY mobile app, the data will go to the SCARY online database when it's submitted. So that information is stored by Woodlands, and it's always made available to the owner of the crossing. So if you want the data yourself, you would contact Woodlands to obtain it, or you can get access to it directly through the online dashboard. So note there are 2 levels of mobile apps for both the GOA and for the SCARY programs. So SCARY and GOA both have a complete inspection form and a simplified version of the form for people to use depending on the situation and depending on their own credentials. So a detailed version of the full assessment requires training, and then the light version can be used by pretty much anybody, and it just collects basic information. It has explanations of how to collect each of those pieces of information, so that the inspector is not having to guess in the field. All that information is provided to them up front. Sorry. The next question. What methodology would you suggest for reviewing spatial data and validating roads? So that's a good question. So something that I do when I'm reviewing data, I look at the data points as they come in a few different ways. So I look at just the information contained, and I look at the individual values to make sure that they all make sense with each other. I review the photos to make sure that, if someone is saying that a crossing is level, that in the photo I'm not clearly seeing that it's hanging, that kind of thing. But then there's also the spatial review. So looking at it from a spatial perspective, I try to see how those crossings basically relate back to what was originally planned and predicted in the field. So I try to see, this is a permanent stream as per the inspector. So from looking at it from a spatial perspective, does it actually fall on a mapped stream? And that'll help me figure out or at least let me flag inspections that may have issues, and then I can review those in closer detail. In terms of validating roads, that's a tricky thing to do. That depends on the quality of your data, to be honest. So as a company, we use DIDS as our road information. So our road layer, sorry. So if that layer is unreliable, then the roads you're looking at and the way that you make those assessments are not going to be right. So if you can communicate with the owner of the roads, if they have spatial information that you can incorporate, that's always a good way of going about it. Relying on data sets that can be flawed will be frustrating, and it'll try to think of a nice way of putting this, but it'll slow down that whole QC process, and it's really hard to validate those things. So aerial imagery is always helpful. I hope I answered that question. Sorry if I didn't. So the next question here is, if staff use SCARY and submit their inspection, does it become, oh, sorry, I already asked that. I already answered that question. Can ABWCI be used as well as in-house apps such as SCARY? Is it good practice that both apps be used at the same time when collecting data in the field? So we do have 2 other panelists, but I feel comfortable answering this, so I'm just going to answer it. Thank you, Bruce and Javed, but that's totally up to you as the person performing the inspections or the organization performing those inspections. So if you want to double the work at the site, so that you don't have to go back, or you don't have to then, let's back up a bit. So the two apps won't communicate with one another. So if you're collecting information in both apps, when you're at the site, you'll have to enter the information twice, basically, whenever you're performing an inspection. So if that's the way you want to go about it, and you see that as being more efficient in terms of time spent at the crossing or overall time, you can do it that way for sure. The way that we prefer to do it as an organization is just use one app. So we use the Scary app that collects all the information, stores it in one place for us, and then we can review it, perform our quality control checks, and then format it in the way that the GOA is asking, and then submit it to them. So that adds some processing steps. It adds some handling steps, which, as I mentioned earlier, does introduce room for error or inconsistencies. But what that also does is it gives you more control over what you're looking at, and it lets you actually perform those quality control steps. Because with the ABWCI app, you collect the data, you submit it, and then it's gone. So you can review those inspections on the app before you submit, but then you can't go back and look at it as a whole. So that's something that I like to do when I'm reviewing Scary data, is looking at it as a whole, incorporating in other pieces of information, like I said, looking at aerial imagery, looking at different spatial layers to try to get as much information about the crossing as possible to make sure that the calls being made in the field make the most sense to the situation at hand. I hope that answered that question. We have time for one more question, so I'll answer one more. Can you submit a batch of crossing inspections to AEP rather than going through the app? So yes, you can. So that's something that we do as an organization, is we collect all the information, like I said, through the Scary app, and then we take it all, we format it according to the GOA's standards, and then we package it and we deliver it to them directly. So then when we do that, we actually still have a copy of the data, which is something that we like to hold on to, because that helps us with our restoration planning later on. So I think that's it for our time, and that's it for the questions that we have. So I'd like to thank everyone for attending today's webinar. No, this was a lot of my voice and not a whole lot of other people. We did have Bruce and Javid, but I answered all of the questions on my own, so that's all right. So yeah, thank you for attending. This is the last week of our webinar series, so we have one more webinar to go through, sorry. So that will be this coming Thursday, June 25th, where we'll have Cody Lund and Tom Bogue from Applied Aquatics presenting about the effects of backcountry use and linear disturbances along watercourse crossings. So if you have enjoyed this webinar, or if you've enjoyed this series, go on to the awccc.ca website and register for that last one so that you can attend that. So I hope to see you all there, and thanks again for attending.